Fáilte Roibh, thank you for joining us today at Sunday morning, early, the last day of your Easter break. Thank you for taking the time out to spend with us looking at areas of mathematics. I've been teaching mathematics for a long time, and I particularly like teaching Leaving Certificate students. It's a subject I know very well, and I find that a lot of students know an awful lot of material, but there are often very gaps here and there in their learning. And with gaps, it means that there are certain questions you can't do completely, and then it might block you from doing other parts later on as well, if that gap is missing. I'd like to reassure you that given that you understand a lot of maths already, there's no part of the course that's harder than others. It's just different. So if you can manage any of the maths on the Leaving Cert course, you can manage it all. It's just really a question of being able to grasp that concept at the time and then adding it to your series of tricks that you have. So what I'd like to do now is I'd like to just welcome you. Normally we would do this in person on the college campus. So if you bear with me, I'm going to just take you through I'm going to change my background view if that's okay. What you're seeing at the moment is you're seeing me coming to you from Griffith College in Dublin. I'm actually physically in Griffith College, Dublin today, though I'm online. And that's a picture of our college campus that you see in the background. It's a 7-acre campus on the South Circular Road. We have another campus that's quite large as well in Cork, where we've got a 5-acre campus in Cork on the north side of Cork on Wellington Road. And we've just invested heavily in that campus over the last year or two, and we're really looking forward to having students back on campus physically in September in the new year, just as we have in Dublin. We have other city centre campuses as well, city centre locations, and here's our city centre location in Limerick. It's in the main centre of Limerick, really, only about a few hundred yards up from the main shopping streets itself. So we've been there many years as well, since 2005. And also we have a new city centre campus in Dublin 1, just up off Henry Street, just off O'Connell Street. In the past, I've delivered this programme to Leaving Certificate students, and 2 years ago now was the last time we did it physically, whereas last year and this year we've been online. But 2 years ago we would have had over 500 students sitting in this room. In fact, I think nearer 700 in this room, both in the tiered seating there, that's our auditorium, and also with extra seating in the front of the hall as well. So we were delighted to welcome you, and it would be wonderful to be able to welcome you there this year as well, or indeed to any of our physical campuses in Cork and Limerick, but it just wasn't possible this year. Hopefully, with the vaccinations coming on stream and the numbers and the relaxations now in COVID restrictions, we'll be looking forward to having all our learners, Irish and international, with us back again in September. There's just some of the physical rooms that we might have used in the past for doing some of the lecture material there, and there's some of our larger lecture rooms as well, as indeed the auditorium. So it gives you an idea of the sort of rooms as well. That's the reception area in Griffith, where people come in, one of the main areas there in Griffith, and one of the standard lecture rooms that we have. Finally, I'll just show you this picture here. This is a lot of the students in the college actually live on campus, and we're lucky to have over 640 places for learners on our campus in Dublin, and we've also arrangements for campus accommodation and family accommodation for international learners in Cork and in Limerick. So there are some of our views. I'm afraid I can't show you those today, but maybe it saved you the travel, and it saved you the extra hour would have taken you maybe to come here, or to get ready in public transport into Dublin, Cork or Limerick. But we're delighted that you're here. Thank you. And we're going to start at 9:30. So I may just take a little break for a moment, but really until then I will just say we'll start at 9:30. What I'll do as well is I want to show you where the notes are today. So hopefully you've got a copy of the notes, but what I'll do is I'll share my screen with you, and I'm going to just show you if I can. Bear with me a second now, and I'll just prepare where I can show you where you can get the notes if you haven't got them already. So bear with me a moment. And basically what I will be doing is I will be sharing my screen with you today. Here's my screen. I'll share it. And hopefully you can see there that I've disappeared into a corner of the screen. And there's the Griffith College website. So www.griffith.ie. If you scroll down that today, you'll see free Leaving Certificate Maths and Maths Resources. If you click on Maths Resources, you can then go to the page on that. And at the bottom of that page, it shows View these resources. And on the viewing of the resources, you can see that's the resource you can get in. You can see a lot of material after today as well. But for today, we've got Leaving Certificate Higher Level Maths Sunday Revision Booklet available here. So if you click on that note there, you will see that the notes there, some information on Griffith College, but also you will see handouts that I will be using today. So later on today, I will be going through functions and graphs, and you will see that you've got 4 slides per page. The slides read horizontally, so this is you go number 1, then number 2, straight across and then down. In the notes, you will see that some slides have a banner heading with no material on it, just telling you what it's about. And every so often in the notes, as you go down, you'll see another heading page, intersecting axes, or checking graph values, or intersecting lines. That's just telling you the start of a particular topic within functions and graphs. And every single topic, every separate topic is examinable by the state in your exams, either if you're doing the Leaving Cert exams itself, or if your teachers are setting exams or setting internal tests or whatever that will lead to their determination on the calculated grades. So these are all the subparts that are required officially on the syllabus. And my intention of producing them like this is that you can then go back and say, I know that bit, but I don't know the other bit. So I'm going to look at that bit again. So we'll be covering material. Some of it you'll know, and some of it it'll come back quickly, and some of it you may want to refresh. Or indeed, some of it you may not have picked up yet, and you might want to look at it once or twice. So there are the notes, and you can just go and print those to your printer, or whatever form you want to use them on, a laptop or an iPad or whatever. So hopefully you won't have too many notes to take down today. So we will go through those notes later. I'm going to stop the sharing for a moment. That's me back. We're nearly ready. We're nearly ready to start at 9:30. So I invite you now to just maybe have a walk around the room, get your glass of water or whatever you need for the 9:30 session, and we're going to start. When I start, what will happen is I will share my screen with you again, but this time you'll be able to see the notes a little bit larger. So for example, here, you can see that you will see my hand here. So this is me, this is my hand, working away on this, and I'm going to say start at 9:30, or starting at 9:30, and the notes you can see are a little bit larger. So I'll be writing on these throughout the day. Hopefully you've got your notes there that you can print. And if you have any queries or questions at any stage throughout the day, please send them to schools@griffith.ie. So that's if you've got questions. If you've got questions, then I'll be able to come back with, and pick those up throughout the day. So we're going to start now at, we're going to start at 9:30. And I'm going to give you that minute to walk around the room, settle yourself in, and I'll be back to you then. Thank you. Fáilte Roibh Isteach. Good morning to you all. Thank you for taking the time out of your day today, Sunday, your last day of your Easter holidays, to look at higher level maths. My job today is to look at 4 topics on the Leaving Cert syllabus and to help you fill in some gaps in that area. So enjoy, and I hope it's really beneficial to you. While we get started, I'm not going to get stuck in just yet. I'm going to start with the warm-up session. And warm-up session is just for us to look at mathematics again and say, what are the things we already know? Now, I know you know all of these before, but I just want to look at how we might use them in the Leaving Certificate. The Leaving Certificate, more than anything else, is about solving equations and inequalities. And if you think about it, the vast majority of questions in the Leaving Cert come down to the following form. X is equal to what? You're asked to find out what X is or Y is or T is or whatever. You're always asked what is the answer to a particular question. So I'm going to start at how we did this all through mathematics to date, and I'm going to start with stuff you know. And I'm going to use that technique and maybe give you a skill that you and an approach that you can use in all of the questions on the Leaving Certificate. So I'm going to start with mathematical operators. You'll find these notes at the end of your notes. It's in the last section there. It's after the probability section in your notes for the Leaving Certificate. So let's go to the very beginning. When you started off with mathematics, the first thing you learned was addition, or well, after the numbers. You learned how to add them, and then you learned how to subtract. And subtract was the opposite of addition. Later on in primary school, you did multiplication and division. And further on, then you learnt about square roots. And when a square root was introduced, you also had a square, which was the opposite. The cubic root was then introduced, and the cube, or the xth root of y, and y to the power of x. So these were all opposites. In the junior certificate, you learned trigonometric functions, sine, cos, and tan, sin, cos, and tan. And you also found that they were linked with opposites, inverse sine, inverse cos, and inverse tan. And then more recently you looked at log and 10 to the power of x and natural log and e to the x. So I'm going to start with a very, very simple question. And I know you know these, so please forgive me, I'm not insulting, or I don't mean to be minimizing what you know. But let's say you're given a question, x plus 2 equals 5. What's x? Well, all of you will say it's 3. I know that, but let's just look at it maybe slightly differently. If x plus 2 is 5, really what we're saying is we just want x on this side. So for x to be on this side, we don't like this plus 2. What's the opposite, or how do you get rid of a plus 2? Well, to get rid of a plus 2, you have to say take 2 from it. So minus is the opposite of plus. So whatever you do on the left-hand side, you must do on the right-hand side. They cancel because that's why you chose it. And x is equal to 5 minus 2, or 3. So it's a slow way of doing what you've been doing for years, but it shows you the steps involved. So x plus 2 is 5, x plus 2 is 5, we're leaving a space there. The opposite of plus 2 is minus 2. That gets rid of it and it unlocks it. So let's see this approach continuing. Y minus 3 is 8. What's y? You'll say 11. But really you might say, well, what's the opposite of minus? Well, the opposite of a minus is a plus. So if I were to put in a plus 3 there, I'd get 8 plus 3. The 3's would cancel and I'd get y is equal to 11. So what we're doing is we're using a linked operator to get rid of something we don't like on the left-hand side. This continued in primary school where we did 3x is 12. It says, well, in this case, the 3 is a multiplier. So I just want x on the left-hand side because that's what the examiner is looking for. What's x? So if 3x is 12, I could choose to divide that 3. Well, I'd have to do the same on the right-hand side. So 3x is 3, 3x over 3, 12 over 3. The 3's cancel, and I get x is 4. Equally, when I say division, y over 5 is 10. What's y? I say, I don't like the 5 on the bottom. to get rid of 5 on the bottom, I better multiply by 5 on the top, on both sides. The 5's cancel, I get y is equal to 50. So it works for multiplication and division. So we now go into squares. We're moving up through primary school and we're saying x squared is 9. What's x? We say, well, what's the opposite of a square? Well, if you look at your calculator, you'll often see that there's a second function there or an inverse, and it might be linked to that, or sometimes it is both. But if I take the square root of that, is the square root of 9. Well, while that looks complicated, all it means is that I chose it to get rid of the square. So the square gets rid of the square root, and then the square root of 9 is plus or minus 3. Similarly, if somebody says, what's the square root of x? The square root of x is 5. What's x? I don't know, but I know how to get rid of a square root. I can just square it. And again, that 2 and the square root kill each other, or offset each other, and then you get 5 squared, x is 25. And the same for something like x cubed. X cubed is 8. What's 8? What's x? I don't know. But if x is cubed is there, I could take the cubic root of it. And the cubic root of 8. They'll all cancel. So I'll get the cubic root of 8. And the cubic root of 8, that's a number. And that's a function of my calculator. So when everything is solved there, I just put in 8, press the button cubic root, and I end up with x is equal to 2. And similarly, the cubic root of x is 3. I don't like that particularly, but I know if I cube it, I'll get rid of it. So the cubic root gets rid of all of that. And I just get x is 3 cubed, or 3 by 3 by 3, or 27. And this continues. For every element in mathematics, for every operator in mathematics, there's a way to undo it. So when you get an answer, or a part answer, in your Leaving Cert question of x to the power of 10 is 1024, what's x? You say, I don't know, but I know I don't like that 10 there, and it's a power, so therefore this must be a root. They cancel. X is equal to the 10th root of 1024. And if that's the case, you type in 1024, take the 10th root. That's generally something like that sort of function on your calculator, or sometimes it's written as this depending on the calculator. And you type it in and you find that's the number 2. And the 5th root of x is 2. I don't like it, so to get rid of it, if I took the power of it, to the power of 5, it would all cancel. And I get 2 to the power of 5, or 32. So it's just a way of eliminating various aspects in the course. When you went through the junior certificate, you did all the trigonometric functions. And here you found that the sign of the inverse sign was cancelling each other out. It's the inverse function. Cos and inverse cos cancelled each other out, tan and inverse tan, and equally if you had them in the different order, inverse sine of sine, inverse cos of cos, and inverse tan of tan cancelled each other out. So how would you do that in an exam question? Well, you're given an exam question and you've done some of the work on it, and you end up with tan inverse x is 45. And you say, but I was asked to find x, not tan inverse. So how do I get rid of an inverse tan? Well, you look at your calculator and you say the opposite is tan. So if I take the tan of it, I take the tan of it on both sides. This looks complicated enough, but really tan inverse is only there for an instant because you chose it to get rid of to cancel each other out. So you're left with x is tan 45. So x is tan 45, 45 is a number, type it in your calculator, press the function tan, and then you get x is equal to 1. Similarly, if the answer was sine x is equal to 0.5, you're asked, what's x? You say, which one is this again? No, you just say, how do I get rid of sine? And you say sine inverse or sin inversa, sine inverse, and you say that cancels that. X is equal to inverse sine 0.5. On the right hand side, you've got a number and you've got a function, no x's, no y's, no nothing. So it's just calculator 0.5 inverse sine, and you'll find that x is equal to 30 if you've got your calculator set to degrees. And we continue there with that. We look at, say, logs, then logs come in, and we looked at log of x. Log of x is equal to 2. How do I get rid of the log? Well, in this case, that's log of 10 to the power of x. So if I take the 10th power of that, 10th power of log x gets rid of the 2 there. So basically I've left with x is equal to 10 to the power of 2, or 100. If that had been a different base, for example, let's say that was log base 5 of x is equal to, say, 2. What's x? Well, what would get rid of a log to the 5? Well, it's 5 to the power. So if I went 5 to the power of this is 5 to the power of that. They'd cancel. X is equal to 25, or 5 squared. So there's always a way to get rid of something on the left hand side. If somebody said 10 to the power of x is 1,000, how do I get rid of a 10 to the power? Well, that's log, again, of base 10. If I took the log of both sides, log of the 10 to the power of x is log of this. Again, they'll cancel, so I'll just be left with my x. And log of 1,000, I type in 1,000, press log button, that's the log 10, and I get 3. And very towards the end now, we're looking at the last one, and we're saying we look at natural log. Natural log, where do I see natural log popping up? Well, natural log x is 3. What's the opposite of natural log? I say, I don't know, but on the calculator, it's e is the opposite. So if I take e to the natural log, now that looks really complicated, but the only reason you did it was to cancel it out. So x is equal to e to the power of 3. So e to the power of 3, e to the power of 1 is 2.71828 to the power of 3, or your calculator will give you an e to the power of 3 as well. So you get that answer, and it's 20 point something. And the last one, e to the power of x is 12. How do I get rid of an e to the power? Well, to get rid of an e to the power, its opposite is log. So if I take the log of this, I can take the log of that. They'll cancel, and I'll get x is equal to log 12, x is equal to that number there. So why did I do all that? Well, I did all that because you're going to do a lot of that today, and between now and the Leaving Cert, and certainly in any test or Leaving Cert exam you do. So how do they work that into the Leaving Certificate syllabus? Well, let me give you an example here. A lot of you will recognize that as the volume of a sphere. The volume V is equal to 4 over 3 pi r cubed. Now, in the Leaving Certificate, there is no way they will give you a formula like that and say, if r is equal to 10, find V. Because that would be too easy. You just stick in 10 where you found r, 10 cubed by pi by 4 over 3, and you'd have your answer. It's more likely that they'd say, if V is equal to 1,000, find the value of r. So they'll tell you that that's 1,000, but you're asked to find r. So, and this is typical of all equations. They won't make it easy with just looking for something on the right hand side with giving you all the values. So in this case, you're looking for the value of r cubed. But conventionally, we would like that to be on the left hand side and for there to be no other stuff around it. So what we could say is that 4 over 3 pi r cubed is equal to V. I've just turned the equation around. That's all I've done there. At least I put, so I mean that's equal to v there. So I've just taken this part down. 4 over 3 pi r cubed is v. Okay, I'll just get some paper here now. Now, how do I make it so that I just have r on the left-hand side? So the first thing I might do is I might say, okay, I don't like the 3 here, so I'm going to multiply both sides by 3. So I get 4 pi r cubed is 3v. Now, I don't like 4 on this side, that's a multiplier, so I'm going to divide by 4. So I get pi r cubed is equal to 3v over 4. I don't really like the pi here, that's a multiplier as well. So given that it's a multiplier, I'll say r cubed, or pi r cubed over pi is equal to 3v over 4 pi. And the pi's will cancel. Now I'm left with r cubed is equal to 3v over 4 pi. But I want r, not r cubed. So how do I get rid of a cube? The cubic root. So what I'm left with is that r is equal to, because they'll all cancel, the cubic root of 3v over 4 pi. Now, if v is equal to 1,000, I just put in 1,000 in here, multiply by 3, divide by 4, divide by pi, and get the cubic root. So that's really what's happening on a lot of the Leaving Certificate questions. You're given some information, you have to move things around, and you have to get things out of your way. So we've seen how you get rid of addition, subtraction, multiplication, powers, roots, trigonometric functions, etc., and logs. So hopefully we'll find those useful as we go through the mathematics for today. So it's just to warm up, just to remind you of just the way you have of clearing the path. It's almost like, I suppose, American football, where somebody has the ball and everybody's knocked out of the way so that the person with the ball can run to the end line or something. So that's what we want to do today. So I'm going to turn our attention now today to an area called functions and graphs. It's the first topic, and hopefully we'll be at this now until maybe about 11 o'clock. It's called functions and graphs. These notes should be at the very front of your notes for today. And what I'm doing here is I'm going through the various subtopics that the examiners can ask. And this is a way maybe of checking off, particularly if you want to do, obviously, the way the math syllabus works and has worked since 2015 is that there is no choice in the Leaving Certificate maths. Before that, you could pick various topics and leave some topics out. Syllabus was a little bit bigger, but you could choose which bits you were doing and which bits you weren't. But with the new syllabus that came in then, all parts can be asked in different questions indeed. One, you can find out there's various parts of graphs in the calculus question, or the calculus in the functions question, or complex numbers can have equations in it, or whatever. So what we're doing here is I'm going to show you that these are all the subtopics. And what you might do is you say, that subtopic there, yes, I know. This one here, I know. Oh, this one here, yeah, I must look at that again, or whatever. So you fill in those gaps so you're not caught out on the day. So we're going to start with something very nice. It's called functions and graphs, and it's a standard, fairly standard quadratic equation there, where you've got just y is equal to x squared minus 2x minus 8. You've seen a lot of these before. I've chosen functions and graphs because they're visual, and it links a lot of areas before. So in all our graphs, and in all the graphs on your course, there are really only two dimensions. There's y and there's x. There's vertical and there's horizontal, because you're writing on a page. You're not building three-dimensional models. So typically you've got just a function. Now another word for y is called f of x. So in any question you see f of x, they really mean y. They mean the vertical. So f of x and x is the horizontal and y is the vertical. Now, if you were asked to define this graph, you could say, well, it sort of comes down and curves nicely and then goes up, and it seems to be symmetrical, which is true there. But if you were asked to define this, are there any points on that graph that are more interesting than others, or more substantial about this particular graph? And there are really, there's a few in that this point here, point A, and this point here, point B, are special because not only are they on the blue curve here, but they're also on this other line here. This line here called the x-axis. Sometimes you don't see it because it's just part of the paperwork, I suppose. But it is another equation. It's another function. And it's a graph where this is 0, 0, 1, 0, 2, 0, 3, 0, minus 1, 0, minus 2, 0. The xy, which is the way we always draw graphs, x first and then y. You read out and then down, or horizontal first and then vertical. But in this case, 0, 0, 1, 0, looks like all the y's are 0. So another definition for the x-axis is the y equals 0 line. So this point A is on the y equals 0 line, and it's also on the blue curve. So if we were to look at the interesting points, we could see that these 2 points, A and B, are the intersection points. And that's a topic that we'll have to be able to do. We'll have to find the points of intersection. We're also asked to find this point here, this point of intersection. That's another interesting point. This is where it's not positive or negative, it's not east or west, but it's on the y-axis. And let's look at the y-axis. 0, 0, 0, minus 1, 0, minus 2, 0, 1. In this case, the first number, the x, this is another way of saying x equals 0 line. So that's the function x equals 0. So this point here, C, is interesting because not only is it on the blue curve, this one here, the function of fx, it's also on this one here where x is equal to 0. Another point of interest on the function, if you look at it like this, you can imagine this being a vase or a vase, and maybe you have a marble in it. And a marble would roll down, maybe roll up a bit, and then roll down, and then roll up a bit, and then roll down. But ultimately at this point here, it would stop. It wouldn't move one way or the other because the slope at that point is horizontal. So that is the minimum point. That's the lowest point in that whole function there. And that's the point where the slope, not the graph, not the value of the graph, but the slope of its change in y for change in x is equal to 0. So that's what we're going to do in functions and graphs. We're going to start by saying, with a function like this, can we intersect and find out this point here, this point here, this point here, and this point here? Every single one of these subsections of your program is worth marks. And you can say that's another few marks, nearer to the course you want to do in college, or the mark you want to get in the Leaving Cert, depending on what course you want to do. So, taking stock for a minute, what are the things that the examiners can ask you to know about? Well, the first one is, can you plot points? And very often you're asked to do this in exam questions. So, plot the function fx is equal to x squared minus 2x minus 8 between the values of x equals minus 2 and 4. So you're asked to plot those graphs. So you say, can I do that? Okay. And we can use graph paper for this. Okay. But really what we're saying is that when you see the value of x here, whenever you see, let's put in the value when x equals 0, x equals 1. They want us to do it between minus 2 and 4. So f of x is equal to x squared minus 2x minus 8. Whenever you see a value of x equal to something, plug it into the rest. So let x equals 1, for example, and let's say x equals 3. So you might just try that for a minute, give those a go and see how you get on. So what would f of 1 be, and what would f of 3 be? So what we do is whenever there's an x, we put in a 1. So in this case, we've got x squared. Then we've got 2 times 1 minus 8. And in this case, we've got 3 squared minus 2 times 3 minus 8. So 1 squared is 1, minus 2 minus 8. And that turns out to be minus 9. 3 squared is 9, minus 6, that'll be 3, minus 8, that'll be minus 5. So we end up with the two numbers. We're saying here that now remember that f of x is another word for y. So the y value when x is 1 is minus 9. So when x is equal to 1, y is equal to minus 9. So the xy value would be 1 minus 9. And similarly, when x is 3, f of 3, or y, would be minus 5. So in this case, we get 3 minus 5. So these are 2 points on this curve. So it looks like for when f of 1, we got minus 9. So this would be the point 1 minus 9. For 3, I think we got 3 minus 5. And that just works out the rest of the points. So there's the minus 1 minus, there's the 1 minus 9 and the 3 minus 5. So we can plot those graphs now on a graph like this. So the 1 minus 9 was go out 1 and down 9, go out 3 and go down 5. And there's the points that we drew on that. And that's plotting the points on a graph, and you get marks for that. They may want you then to draw it as a curve, and you can buy one of these flexible things in Tesco or whatever your local shop is, or Aldi or whatever they have it. But generally, you'll find these somewhere locally in Dunn's or whatever. And you just decide then to maybe or you can do it by eye. You won't be losing marks for it being slightly less smooth or something like that. But you get an idea of how the curve will draw. And there's your plotting of your graph. There it is, slightly better. And you get marks for that. So that's something that, can I plot graphs? Yes, I can. Great. Know how to do it. Doesn't matter what the curve is. Just put in values, draw the curve, pick up marks. Great, we're moving. Now, next topic. The examiners will say, can you find out where functions intersect the axes? And the axes, we mean the x-axis and the y-axis. So here we're trying to find out on the curve, can you identify the points where they intersect with the x-axis? And can you identify the points where they intersect with the y-axis? So let's take the intersection of the x-axis first. The intersection of the x-axis here, though we don't often see it, because we're used to seeing the paper and think there's nothing on it, we just haven't drawn anything yet. But even in its basic form like that, this one here is the y-axis, and this is the x-axis. And if it's the x-axis, it means that there's no y value. So y is equal to 0. And in this case, there's no x value, it hasn't moved out east or west. So this is x equal to 0. So really we're asking here, if we go back to this curve, we're saying this point here A and this point here B, really what's going on? Well, what's going on is that the point A and the point B, not only are they on this one, fx equals, but they're also on this one, the y equals, or fx equals y equals 0. So really what we have now is we have this equation here is written as fx is equal to x squared minus 2x minus 8. But we also have fx is equal to 0. And they're both true. So because they're both on A, and if they're both true, we can say equals 0. So x squared minus 2x minus 8 is 0. That's the point of intersection. So at this stage, what we have is we have an equation that says x squared minus 2x minus 8 is 0. And we're asked to solve that. So we're asked to solve that. And that is another part of your course. It brings us into quadratic equations, but we'll do it here as well. Some people will like to solve this by using factors, and they'll say, well, the factors of x squared are x and x, and the factors of 8 are 8 and 1. I don't think that'll work. It can give us one in the middle, or maybe 4 and 2. That seems possible. We'll go for minus 4 and plus 2, and that would give us x by x using the multiplication out. I think the Americans call this the FOIL method first, using the first ones. X by x is x squared. Outside, x by minus 4 is minus 4x. 2 by x is plus 2x. And 2 by 4 is minus 8. So we get x squared minus and plus will give us minus 2x minus 8. That looks like it's the same as this. So the factors are x plus 2 and x minus 4. If x plus 2 and x minus 4 are the factors, that means that either x plus 2 equals 0 or x minus 4 equals 0. And if x plus 2 is 0, we would get rid of the 2 by making it a minus 2. This becomes minus 2. We get x equals minus 2. Here, to get rid of a minus 4, we'd add 4 on both sides. So we get x equals 4. So these are called roots. So we found that when x is 4 or x is minus 2, this function, they're called roots, and they're called factors. Or graphically, when x is 4 or when x is minus 2, we've intersected with the x-axis. And that's what we were asked to do. Can you find out where a graph intersects the x-axis? Yes, I can. I just make the two of them make them equal to 0, solve the quadratic equations, and we're done. Now, some people would have spotted that x squared minus 2x minus 8. Others would say, I didn't spot it, so I'm going to use the sledgehammer approach of the minus b plus or minus that we learned in the junior certificate. So x squared minus 2x minus 8 is 0. It works for any quadratic equation, ax squared plus bx plus c, where a is the first coefficient, b is the second, and c is the third. So I say the first coefficient, if it's x squared, it's 1x squared. So I go into a lockdown zone, or sorry, bad term, but a concentrated zone, and I say a is 1. For this equation, b is minus 2, and c is minus 8. Okay. So I write those down, and I'm going to use the equation of the minus b. So I'm going to copy those to the next page. And I have them here. And I say x is equal to minus b plus or minus b squared minus 4ac. I'll pick up marks for this. All I've done is I've copied this exactly from the log tables, from the formula tables, and then I just get into the zone again and focus. Minus b, copy down, is minus minus 2, which is plus 2, plus or minus the square root. B squared will be minus 2 squared, minus 4 times 1 times minus 8, all over 2 by 1. Okay. So now I can come up for air. I've written them all down. Now it's just pure, I suppose, numbers. Plus 2, plus or minus, 2 squared is 4, and 4 by 8 is 32, so that's 36. And the square root of 36 is plus or minus 6. So if I take the first one, 2 plus 6 over 2, I get 8 over 2. 2 minus 6 over 2 is minus 4 over 2. Note I get the factors x equals 4 or x equal to minus 2, exactly as I got before. X equal to minus 2 and x equals 4. And that's how I found the intersection of the x-axis. I either found it by, now they may ask you to do it by eye, but if they ask you to do it by formulae, you take this equation, you make it equal to 0, you find the roots of the equation, and you're done. What else can the examiner ask under intersecting axis? Well, the examiner can ask for intersecting the y-axis. The y-axis is the vertical one. In this case, x is equal to 0. So if we consider point C here, what's special about point C? Point C is special because it's on the y-axis, the vertical, which often we don't see. It's on this one. Because it's just, we're so used to seeing it, we lose awareness that it's actually an equation, and the blue line as well. So, or the blue curve. So really what we're saying is that this is true and this is true. So what does that mean? It means that y is equal to x squared minus 2x minus 8, but also x is equal to 0. So if x is equal to 0, y is equal to 0 squared minus 2 times 0 minus 8, or minus 8. And f of x is really y. So your xy value turns out to be 0, because that's what you were told x was, and minus 8. And that's it. So you're picking up marks. It's in the early part of the exam, but you're picking up the marks and you're saying, can I intersect a curve with the y-axis and the x-axis? And that's it. So with those skills, the examiner then says, are there ways of actually stretching that? Can we ask you to do other things and check other things about graphs? Well, in this question, they say, is the point 0, 3 on the graph? Well, I think clearly you can see it's not, but how would you prove it? Well, is the point xy of 0, 3 on the graph y is equal to x squared minus 2x minus 8? And really it's a question of plugging in the numbers and seeing. So if we written formally like this, check whether or not the point xy equals this satisfies the function. Really all they're saying is this point 0, 3 on this curve. So let's plug it in. 0, 3. 0, 3 would say, let's see what we get when we say f of x is 0. Well, we say when x is 0, we get 0 squared minus 2 times 0 minus 8. f0 is 8. Is that equal to 3? It's not. So minus 8 is not equal to 3. 0 minus 8 satisfied the function. 0.3 does not satisfy the function. It's not on the graph. So he plugged it in and we said, we could have done this. We could have said, is that equal to 3? Equal to 3? Equal to 3? It's not. What else can they ask? They might say, where is the value of where is the fx? Again, remember that graphs are only two things, x and y. So when they say, where's f of x? They say, where is f of x greater than 0? Where is y greater than 0? Where is y greater than 0? Where is, well, let's look at the y, the x-axis. This is the y equals 0 line. This is y equals 1, y equals 2, y equals minus 1. So when we start looking at y greater than 0, we mean everything above here. So what we're looking for here is, where is the function f of x greater than 0? F of x is greater than 0 when it's above the line. So we look at the curve here and we can see that as we go from 4 on, that the blue curve is up here. Similarly, before minus 2, the blue curve is up here. So in this area and in this area, f of x is greater than 0. Now at the point here, it's greater than or equal to just at that particular line. But to the left and to the right, it's greater. So that's what we're asked to do. And here, it's below the line. So you can imagine this being mountains and this being a lake and this being the ground or something like that. So you've got mountains, then the body of water, and then you're up above the water again, and this would be the surface of the water. So effectively, when x is greater than 4 or x is less than -2, fx is greater than fx is greater than 0. If they wanted it greater than or equal to, they would have been less than or equal to. It's just whether or not you include the margin or not. So how you might write that is you would say when y, you do it by I, or you'd see it on your graph if you'd solved the points of the factors and the roots, the points of intersection. So you'd say when x is greater than 4 or when x is less than 2. So they're the two parts. Now some people might like to say, well, I'd like the -2 to be on the other side because it's a negative number or something like that, or I want to put them in order. If x is less than -2, then as you go from x to -2, you see the pointy bit first. So if I put x on this side and -2 on this, I'd have to see the pointy bit of that sign first. Similarly, as I go from -2 to x, I see the open bit first. So in swapping it, that's what I get. So I get -2 is greater than x, and x is greater than 4. So I get -2 greater than x greater than 4. Or I could join these and just say -2 greater than x greater than 4. So that's what's going on there. I've got -2 greater than x and x greater than 4, or I have it as just simply one equation there. And that's how that works. And that's the end of that subsection where they ask you a particular question and they say, that's how we see how that's going. Okay. We're nearly 45 minutes in, so we're just going to take a breather now for a minute, give ourselves just a second before we start on intersecting lines. Okay? Thank you very much. I understand there are some questions coming in, which is great. And you're commenting on the comment line as well on YouTube. So thanks very much for that. And we'll see those. I hope to answer those then over the breaks as we go through them. So let's continue now with intersecting lines. In a way, we've chosen intersecting lines before, but we'll now do something other than the x and the y axis. Exam question. For what values of k does the function fx is equal to, or y is equal to fx is equal to k intersect the function twice? So here we've got a graph, and we're saying here we've got the lines, apologies, and here we've got the nice curve, and we're saying if I just have a ruler or something like this, and I start going down, 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 you can see that if it's a horizontal line, y equals 4, 1, -2, etc., it cuts the graph twice. But at some point here, it only cuts it once. And below that, it doesn't cut it at all. So the question you're being asked here is, for what values of fx is equal to k, y is equal to k? Now, y is equal to k is just a straight line. It's just well, y is equal to k is y is a number, y is equal to 1, y is equal to 0. They're all lines that are horizontal. They're parallel to the x-axis. So the question is, what values of k cuts this twice? So we've got to go down, 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 until we hit this point here. Really, we can do this by eye, and we can see that at the point y equals -9, it only cuts it once. And they can ask you to do that by eye. Or they can ask you to do that by finding when is the slope equal to 0 and where is the minimum point. So we're now flipping from functions and graphs into calculus briefly. I'm not going to cover all the calculus questions here now, but later. And we'll say, where is that point? So visually we would say, when k is greater than -9, when k is greater than -9, we're going to cut it twice. But above, at -9, it cuts it once, and below it, it doesn't cut it anymore. But very often when they have a functions and graph question, they move into the calculus part of it, and they say, find the maximum and the minimum of a particular curve. Now, very briefly, the slope of a curve is given by dy dx, the change in y over the change in x. And it's also written as f dash x. It just happened that in the 17th and 18th, well, the 18th and 19th centuries, really, where they were doing a lot of work on calculus, that there were two different ways of writing it down. And one school followed the f dash x line, and the other used the dy dx. And they're both with us today, but they're really the same thing. It's also important that when we talk about things like slope, that on the line question, we use a letter called m. And m is another word for slope. So it's the same thing. So slope. So when they talk about slope or m or dy dx or f dash x, they mean the same thing. Really, when dy dx is there, they're saying the change in y over the change in x. So the change in y, y2 minus y1 over x2 minus x1. And you'd have seen that in the equation of a line, or delta y over delta x. So it's all the same thing. They're just saying the slope. As you go out in the curve, as you go out in this direction, how far up do you go? So between point A and point B, you went out, this is the change in x, this was the change in y, and how steep was that? Were you going uphill, or were you going downhill at the time, or were you just going horizontal? So to calculate the derivative of the original function, now we do this later in calculus, but in calculus, there's a way of calculating the derivative of a function in x. So we say y is equal to x squared minus 2x minus 8. And there's a general formula that says if y is equal to x to the power of n, dy dx is got by taking down the power on the top, n, and reducing it by 1. So for example, dy dx here, you take down the power of the 2 and you call it 2x and you reduce it by 1. For the x, it's x to the power of 1, so you just take it down and the x goes away, so minus 2. And for a constant, constants don't change. So for dy dx, you get for this equation here 2x minus 2. So 2x minus 2 is called the derivative. Derivative, another word for that thing, another word for slope, another word for all those points there. So derivative, slope, dy dx, they're all the same term. Okay? Now, find the derivative when the function is equal to 0. Well, here we're told that the derivative is always 2x minus 2. But when is that equal to 0? So we say 2x minus 2 is equal to 0. Don't like the 2 on this side. I'm going to put a plus 2. So 2x is 2. Don't like the 2 as a multiplier. So I get x is equal to 1. So find when the derivative of the function is equal to 0. Now, find the value of the function, not the derivative. So we have to remember here that the words they use are very precise. They say, find the value of the function. The function was x squared minus 2x minus 8. The derivative was 2x minus 2. So when they say, find the function, that's it. Find the derivative, that's it. But when they say, find the value of the function at, well, when x is equal to 1, they want you to put in f of 1. So you put in f of 1, 1 squared minus 2 times 1 minus 8 is minus 9. or if they wanted the value of the derivative at that point, put in 1. 2 times 1 minus 2 will be 0. That is correct. We want the derivative to be 0. We want the slope to be 0. So there's the minimum point. The minimum point is a graph there. To find the minimum point, we know that the fx is horizontal, so f dash x is 0, dy dx is 0, the derivative is 0, the slope is 0, the m is 0. And we find it by saying, we then plug in the 1 into this, 1 squared minus 2 times 1 minus 8. So the question now is, yep, I know how to do those. Yes, I know how to find the minimum point. Yes, I can move on to another topic. Okay, how do they extend that skill that you have? And they say, well, you found derivatives, and you found where the derivative is equal to 0. But the derivative can be equal to any value. So in this case, they say, find the slope when it's equal to a different value, not just 0. The same idea, same skill, you just don't end up at the minimum point. So here's a graph, and they say, find the point where the slope is greater than or equal to 0. You've drawn the graph, and by eye, they want you to find out where is the slope greater than 0. So you look across here and you say, if this was a vase and it was rolling down or up the hill, certainly at this stage I'd be going downhill. Here I'd be going uphill. So if I was walking on a mountain, I'd be going, well, from the lake it would be pretty tough, but if I was walking up a mountain, I'm certainly going uphill as I go up here. So from this point on, the slope is greater than or equal to 0 from this point on, when x is equal to 1. So after x is equal to 1, the slope has gone up. I can see that by eye. So how would I find that? Well, the first thing I do is I find the original equation. Then I find the slope. How do I find the slope? The derivative, the dy dx. I just do the calculus. X squared becomes 2x. Minus 2x becomes minus 2, and the 8 disappears. So the question now is, find when the slope is equal to 4. Find when the derivative is equal to 4. Now, for the derivative to be equal to 4, it means that for every step out I go, I have to be going up 4. So for every step here, 1, I'd have to be going up 4. Now it's probably more than that there, but that's my x and that's my y. So I want my y to be 4 times my x. So, but I have a formula. I have a dy dx is equal to 2x minus 2. Always. I have a formula for the derivative, and the derivative says that's the value of it all the time, but I want that at this stage to be equal to 4. So at this stage, I want 2x minus 2 to be equal to 4. 2x minus 2 to be equal to 4, I'm going to take the 2 over to the other side. So 2x is equal to 4 plus 2, or 6. And then divide, I get x is equal to 3. So this is telling me that if I go out to x equal to 3 and down here, at that point there, the slope is for every step out I go, I have to go up 4. Now, find the value of the function at that point. To find the value of the function at that point, well, firstly, I know that x squared minus 2x minus 8 is the function. F dash x is 2x minus 2. It's useful for you maybe to write down the words function and slope, because then you know what equations you're looking for. So find the value of the function. Function, it's this one. At that point, at the point 3, whatever that point was, 3 minus 5 or whatever it was, at the point x equals 3. Well, now I've got to say when x is equal to 3. So I take this function and I put in f of 3. So 3 squared minus 2 times 3 minus 8. So I calculate that as 9 minus 6 minus 8 over 5, just as I did using the plotting of the graph way back. And I find that at the point 3 minus 5, the slope is 4. So there I am at the point 3 minus 5. The slope, the dy dx, m, the first derivative, f dash x, is equal to 4. So for every 1 I go out here, I have to go out 4 at that point. So that's 4 times this. That's whatever that amount is. That's 4 and that's 1. That's 4 and that's 1. And that's how we do that. So when the point is 4, you can see dy dx, slope m, 4, that's it. So now we've come through quite a bit of the mathematics that they ask you on functions. We'll do a few more. We now link the functions and graphs to tangents. Given that you found the point, at a point the slope, and the point where the slope is 4, you can see that at this point here, where the slope is 4, it's actually a tangent if you were to draw the line. So let's link it now while we can to the actual line part of your course. And we say, can you find the tangent to a curve? We'll find the tangent to the curve. Here's the curve, x squared minus 2x minus 8 at the point. But what do we know? We know that the point is 3 minus 5. To find the tangent, we've got to find the slope. We just did find the slope because we found the derivative, or the dy dx, and we found that the slope was 4. So m is equal to 4. And one of the points is 3 minus 5. And 3 minus 5 is x1, y1. What we'll find in the exam is we'll use the tables that they give you an awful lot. You get marks for referring to them, you get marks for identifying the right one, and you get marks for transcribing that equation into your exam paper. So what we're doing is we look up, is there a way of solving this if I know m and I know a point? Yes, there is. There's an equation for this. It says the tangent is given by y minus y1 is m into x minus x1. So this is an equation in the tables. I can look it up. Y and x I can identify. Y1 and x1 I know, and m I know. So it's just a question of copying that equation and then plugging in the numbers. So here again, I copy in the equation exactly from the tables. I've got my zone here of 3 minus 5 is my point. M is 4. And I say, okay. I carefully go into it and I say y is y. Y1 is minus 5, so minus y1 would be plus 5. M would be 4. X is x. Minus x1 is minus 3. So I write that equation out. And over the next series of steps, I decide which way I want to go. The 4 into x would be 4x minus 12. And I copy them across, moving things left and right as I wish, until I end up with either this equation or this equation, whichever way I want to do it. If I want x on this side or y on this side or whatever. So that's how I get that line. Y is equal to 4x minus 17. And that's one way of drawing the line. Another way of writing it might be 4x minus y minus 17 is 0, or 4x minus y is 17. Depends on whether I want it as a simultaneous equation or in the format of a line or whatever. So there's my y is equal to 4x minus 17. I found the tangent, it's at that point, and I pick up marks. And if I wanted dy dx of 4x is just 4. Proof that it is the slope at that point, m is equal to 4. So that's how I do that. So what have I done now? I've done intersecting lines, I found out the slope, etc. What else can they do? Well, they can ask a few more questions. They can say, let's intersect functions. I thought I just did that. We did that for the x-axis, we did it for the y-axis, and we did it for tangents and all that. But maybe functions can be a little bit more interesting than that. Okay, so find where the function f of x intersects this function here. What's happening here in the exam is they're giving you two functions, but there's no difference to the challenge from the maths point of view. Here's one and here's another one. Well, if you can do one, you can do another one. It's just more of the same, really. And they say, find where the one function is equal to the other. So find out where these functions cross. Now, they may ask you to draw these, but let's assume they don't, and they just see it as algebra. They say, when is fx equal to gx? Well, when fx is equal to gx, this thing here, which is fx, must equal gx, which is this thing. So effectively, on the left-hand side, you've got fx, which you've copied down, and on the right-hand side, you've got gx, which you've copied down. So x squared minus 2x. Now I'm just going to copy these things across. I don't like the minus x on this side. I'm going to bring it over and it becomes plus. I don't like the minus 2 and it'll become plus. And the rest is the same. X squared minus 2x plus x would give us a minus x, and minus 8 plus 2 gives us a minus 6. So effectively what I have now is I've got another quadratic equation. And if I wanted to solve that, I could say solve it with factors. And the factors for x squared are x and x. The factors for 6 are minus 3 and plus 2. And I find where x equals 3 or x equals minus 2 that it solves. If I didn't spot that, I could go back to the previous way and use the minus b formula, go through the various questions, put them all in, copy them down, just as I did a minute ago, and I'd find that I get the same two answers, x equals 3 or x equals minus 2, just as I did earlier on. So calculating the points on the functions then, well, if gx is equal to minus 2 minus, or minus x minus 2, g of 3, when I plug in the number 3, is everywhere there was an x, I put in 3. So 3 minus 3 minus 2, I get minus 5. When g is minus 2, I get 0. So it looks like the points of intersection are 3 minus 5 and minus 2, 0. So checking the process with respect to other function using the same values. Well, I'm going to do the same and plug in the same values of f of 3 and f of minus 2. And I'm going to see how I get on here. And when I get 3, I get, when x is 3, I get 3 squared minus 2 times 3 minus 8 is this. And f of minus 2, I get 0. So it looks like the 3 minus 5 and the minus 2, 0, just as I did with plotting points, are exactly the same for gx. And if I drew them, you can see here that point minus 2, 0, A, and this point here, 3 minus 5, are on the blue and on the red. So that's how that works. So we'll continue now using the same techniques as we saw before. And we're asked, yes, we've got the two curves, but at what stage is the red curve above the blue one, and at what stage is it below? So let's look at this at the moment. At the moment, you can see that at this point here, blue is higher. So for example, at the point minus 3, you've got the red value here, but the blue value is way up there. And for example, at the point 4, the blue is way above the red. The red is just going down, 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 down. But at this point here, between A and B, you can see that the red is above the blue. There's clear difference between the red value. The red value, for example, at 0 is minus 2, but the blue is minus 8. So you're asked, where is f of x greater than g of x? And you can do that by observation. So you can go back and you can say, by observation, I reckon that it's between minus 2 and 3. So there you can see that in this section here, f of x is greater than g of x, and in this section f of x is again greater than g of x, but here f of x, the blue one, is below g of x. So you can do it by observation, and you can say when x is greater than 3 or x is minus 2. And again, you can say x is less than minus 2, x is greater than 3. We can change this one around and say minus 2, open mouth, x greater than 3. And that's how we resolve that. So we're moving through the notes and we've a little bit more to do. So again, you might want to just catch your breath there for a minute. Thank you for the questions coming in. I look forward to looking at those at the break at 11 and half 11, and I'll get to those at some stage later in the day. Or indeed, if I have to get back to the individuals as well, as long as your email is on it, I'm happy to do that as well. So let's look at another way they can add to the standard of the Leaving Certificate. Here we've got functions and graphs, and we've got inverse functions. So plot the function fx is equal to 1 over x plus 2. Now, this is often another section of your notes, another section of the exam questions, but it's really the same as before. What is it? It's a fx, it's a value of y, equals something with the x values on the right-hand side. So you can say, what's the value of f naught when x is naught, when x is 1, when x is 2, when x is 3, and you just draw the graph. The numbers turn out to be whatever they are, and then you plug them in and you put them on a graph paper. It says don't do it when x is equal to minus 2. But again, you just plug in numbers from minus 6 to 2 and you find them. So for example, if I do f of 3, I get 1 over 3 plus 2, which is a fifth. So the numbers turn out to be quite small. You do them for each of the 2 pages. And what happens is when you draw them, you'll find that you get this curve here. Nothing magic about it, it's just that's where the points ended up. That's where your values ended out. Just as you did when you draw any other curve, that's what you get. And it's an interesting graph because when x equals minus 2, you can see that the graph doesn't make any sense because minus 2 plus 2 would be nothing, and 1 divided by nothing is not defined. So that's all that's going on there. What else do they ask you to do in functions and graphs? Well, let's look at cubic graphs. Cubic graphs are nicer, I suppose. They're more interesting in that you've got y equal to an x cubed plus x squared plus x's plus whatever constants. And if it's an x cubed, it'll actually turn twice. So it's smooth again. It goes up and down, or it might go down and up and go like that. But basically what you'll find is that it turns twice. It's got a maximum and a minimum point as well. So that's a nice curve there. And you might be asked to find the roots. In this case, in this graph, the roots are at minus 1, 2, and 5. A cubic graph will have a turning point. It will have a max or a min. It'll actually have both. So here you can see that the slope of the curve, if we were turning, that would be a mountain at the top and this would be a lake in the bottom or something. That would be when the slope would be 0. And we've got to find those 2 points. So the dy dx, the f dash x, the first derivative, the slope are equal to 0. Here, between the two, if you imagine you were turning a car and you turned a corner and then you had to go into another bend, at one stage you'd be just coming out of one circle and you'd be turning into the next. And that's the point of inflection. And that's where d2y dx squared or f double dash x is equal to 0. So they're the things you need to be able to know. Here I've drawn the cubic graph, but I've also taken the derivative as well. So not doing calculus at the moment, just yet in this section. If I take dy dx of this, or if this is f of x and f dash x, the rule is that you take down the power and you reduce it by 1. So 3x cubed becomes 3x squared. In this case, the x squared will become 2x. Multiplied by 6 would be minus 12x. The x would just disappear, leaving the value 3, and the 10 would not be considered at all. So that's the derivative graph. What I've done here is I've drawn the derivative graph here. And I've drawn the derivative graph just to show you where things happen. So, for example, when the first graph is at a turning point at the max, then its slope is 0. So the slope, the derivative, is 0. And equally, when the first graph is at a minimum, its slope is 0. And when the first graph is at a point of inflection, turning between the top and the bottom, its derivative is 0. There I've decided to draw in the second derivative, so I've taken the f double dash x of that. 3x squared, well, the x squared will become 2x, that'll become 6x. The minus 12x will become minus 12, and that's a straight line, because it's really just a y is x no squared, so it's a straight line. So that's the second derivative, and you can see that when the first derivative is at a minimum, the second derivative is at 0. And then the last one is just, if I took the third derivative, just for the sake of it, for completeness, I'd get 6. Y is equal to 6. That's the line there. Okay, there's no change. You can see here that the slope, the third derivative, is always 1 to 6, 1 to 6. There's the same ratio all the time of dy dx. So that's that. So what else can they ask? Well, they can go for logarithmic and exponential curves. So they say, here's a graph of f of x is log x. There's a nice graph of it, and you might have to plot that by plugging in log of 1, log of 2, log of 3, and all that. And here's the derivative. What's the derivative of log x? Well, we can look it up. Again, we should do that. We need to use the tables a lot. We say, they've given us the values for this. What is the f dash x of log x? And I can look that up, and I can find that it's actually f dash x, if fx is log x, f dash x is 1 over x. And that's given to you in the tables. You look it up and you say, okay, well, if the formula is now 1 over x, when x is 1, it's 1 over 1. When x is 2, it's 1 over 2. And I can draw my graph. So one of those is f of x, that's the function, and that's its derivative. Similarly, if they ask you to draw f of ex, exponential to the power of x, you can draw that. You can say what's e to the 1, e to the 2, e to the 3, and e to the 0 is just 1. E to the half, e to the quarter, e to the minus, all the way back. And then if you want to get the derivative of that, again, you look up the tables. What does it say? That column that says what are the first derivatives of e to the x, f dash x, turns out to be e to the x. So it's the same curve again, as is f double dash, f treble dash, all the way down. So if y is equal to e to the x, dy dx is e to the x, d2y dx squared is e to the x, and that's just the curve of it. And finally, before we look at some recent exam questions and just see how this works, what other graphs can they give you? Well, if we look at other graphs, we can say, okay, most of the graphs to date have been very smooth. They've been very nice. They've been sort of straight lines, or maybe quadratics or cubics or whatever. And they could be smoother if they could be like that, but they don't sort of, they're not pointy or angular in that sort of way. But here's a graph that they can give you, or a type of graph that they can give you, and it can be sharp and edgy like this. Note that they write it like this: f colon x is arrow fx. It's a new language, a new set of symbols, but really it's the same thing. We still have paper, we still have y, we still have x. We've only 2 dimensions. We've only got a vertical and a horizontal. So one of those must be y and the other must be x. So here's a graph. And we do see these graphs sometimes, certainly on, say, TV programs where you might have somebody in a hospital and he or she might be switched to a heart monitor. And then for a while they go like this and it gets interesting, and you're hoping that, or whatever, depending, that you want that thing to kick back in at a certain time. So there are lots of functions like that. And what they would like you to do is to find out what's the period, how often do they repeat, that's what they mean by that, And also, what's the range? How high are the values? What's the highest value and the lowest value of the curve? So here's a fairly simple one, a fairly standard one. And they say, in this pattern here, there's the pattern, identify the period and range shown in the graph. So here you've got your graph going like this. How quickly does the pattern repeat? Well, you can look at this and say, looks like if we take the top bit, that's the top, that's the top, that's the top. They seem to be the same distance apart, so I think I've got the period right. That's the number 6, and that's the number 16. So if that's 16 and that's 6, that must be 10 difference. That's minus 4, that's 10 difference. Equally, I could have chosen the bottom ones and done it that way. Or maybe where it crosses the x-axis on the way up. So that would be minus 2 to 8, that would be again 10, 10. So that's how you find the period. And find the highest and the lowest value. The highest and the lowest value, well, it looks like here we're below the y-axis, and here we're above, or below above the x-axis, sorry. Y here is minus 1, and y here is 3. So the range here, we just read it off. Now what can they ask you to do from the graph? They can say, find f4 from the graph, and also estimate f of 84. So having drawn the graph, they just gave you a picture, and now they say, okay, let's have a look at that. What's f4? Well, you go out to 4, because f of 4, remember, that's the y value, so that must be the x value. The f makes it the y, f of it makes it the y. This must be the x value. So you go out to the horizontal of 4, and you go up and you say, looks to me like it's 4, 2. And that's your marks for that. You've read it roughly or approximately or accurately, depending on if you went through it or not. Now, find the value of f84. Now, this is trickier. Here you've got the graph, and it's going maybe to 4, 10, 20, but it doesn't go to 84. So how do you find that it doesn't go to 84? Well, it looks like this thing repeats itself every 10. So if it repeats itself every 10, f of 4 must be the same as f of 14 or f of 24. So how would you find it? Well, really what you do is you decide to take 10 from 84. And you say, what's f of 74? I still can't see it. And you just keep on taking all the 10s you need. So 64, 54. How many 10s are there in 84? Well, there might be, say, 8 10s. So what you do is you say, to find f of 84, you say, well, given that the pattern repeats every 10, we can take 10 from it as many times as we want. And 84 divided by 10 is about 8. So if we took 8 10s from 84, we'd be left with 4. And f of 4 we know is 2. And that's how we do it. And that's all that's involved. So they're all the tricks that we can see. A lot of things we've covered there. We've linked a lot of the courses together. Started off quite light, but go through the various topics there. And hopefully we've filled in some of those. So thank you very much for that. We're going to move now to just a few questions to show how they would come up and how they do come up in the exams. Taking some recent questions. So if you'd like to get a piece of paper and a pen and just get ready, and we'll see how these go. Remember, all of the exam questions, it's a really fabulous resource. The State Exams Commission exams results or exam site is really useful. I know it's not the easiest to navigate and all that, but in terms of the questions, all the questions that have ever been asked are there. All of the marking schemes that have ever been given are there. So you can look at every single question and focus on the bits. Maybe sometimes you're in good mood and say, I know this, I know that, I know this, but focus on the bits you don't know and say, what was that bit again? Oh yeah, and add that and fill in the gap to your knowledge. So I'm going to start now with a recent exam question. These are all 2019 or 2020, but you can go back to them all and you'll see how often they do come up. So, leaving certificate higher, question 2. 2019, the graph of the function f of x is 3 to the power of x, cuts the y-axis at 0, 1 as shown below. So you're given a picture and you're given a graph. Y is equal to 3 to the x, which is great. Draw the graph of the function g of x equals 4x plus 1. So, as we started on this section, we said plug in the value when x is 1, what's g of x, when x is 2, when x is 3, when x is 4, and draw that graph. Use substitution to verify that f of x is less than gx when x is equal to 1.9. Now, I'm not going to do this question, but really what they're saying is that this is f of x here, because the answers are all on the website. But that's f of x. I'll explain how it's done. G of x is a straight line. So let's imagine that g of x is, well, it's going up in a certain direction. And let's say that g of x turns out to be something like this. That's g of x. It'll be a straight line anyway. So if it's a straight line, it's going to hit this curve at some point. And you're asked to say, show that f of x is less than g of x at a certain point. So at some stage, the blue line is above f of x, and at some stage, it's below. And you're asked, where is f of x less than g of x? Is f of x less than g of x at a certain point, or is it above it? And let's say they picked the point 1. Well, at the point 1, I think f of x will be below. At the point 2.5, f of x would be above. How would you find that out? Well, you could do it by visually on the graph, or use substitution they're asking for here. So if it's the point 1.9 they're looking for, they're saying, okay, how do we do that? Well, f of x is 3 to the x. G of x is 4x plus 1. And they're interested when x is equal to 1.9. So what you do here is you say, in the first case, you say f of 1.9 is 3 to the 1.9. G of 1.9 is equal to 4 times 1.9 plus 1. And you work that on a calculator, and you work this on a calculator. And whatever is bigger is the answer. So that's it. So there's your marks for that. Here's another exam question. This is 2020. And we look at this and we say, excuse me, the diagram below shows two functions, f of x and g of x. So here we've got a nice curve, and this is the f of x, and the straight line one is the g of x. Again, very similar to what we've done in the example and in the previous question indeed. Okay, f of x is given by x cubed plus k x squared plus 15x plus 8. Now, given that f dash dy dx, let's get, this is the function, and we'll call this the slope. So we know which one we're talking about. The slope is the first, well, the slope of the function is the first derivative. X cubed, we take that's 3x squared. The x squared would become 2x by k would be 2kx. 15x would be 15, and the 8 would be left alone. So that's our equation for slope. That's our equation for function. Now, what are they looking for? Given that f dash 3, so they're saying f dash 3, in other words, when x is 3, they're saying that would be 3 squared plus 2k times 3 plus 15. Given that that is equal to minus 12, find the value of k. So 3 by 3 would be 9 by 3 is 27. 2 by 6 is 12, so 12k plus 15 is minus 12. We should be able to solve that because we should be able to say 12k on this side minus 12 minus the 15 minus the 27. And effectively then, to get rid of the things, we can add, sort that and divide by 12, and that's our answer for k. So show that k is equal to minus 9. So this turns out to be k equals minus 9. The function gx is the line that passes through the two turning points. So it's saying that g of x, the blue line, passes through the two turning points, this one and this one. So it goes through the turning point on the top and the turning point on the bottom. Find the equation of the line, I think. Yeah. Well, really, what are we looking at there? Can we find the turning point? How do you find a turning point? You find when the f dash equals 0. When is the f dash equal to 0? Well, when this one, the slope, is equal to 0. But we also now know what k is. Remember, k is minus 9. So really what we have is we've got an equation that says that f dash x is equal to 3x squared. I'll put in the value for k. I'll get, well, it was plus 2kx plus 15. If k is equal to minus 9, I get 3x squared minus by 2 is minus 18x plus 15. And that's the slope. Now, when are you at a turning point? When the slope is equal to 0. So effectively what you've got to do there is you've got to solve that. You might be able to spot that with factors, or you may have to use the minus b plus or minus. But if you use it either way, you are going to find out that when x is equal to something, a, and when x is equal to b, that's where the thing is 0. So in other words, using the techniques we've learned, we can find that this is when x equals a, this is when x equal to b. Now when x is equal to a and x is equal to b, you found where the slope, either max or min, is 0. But to get the point, you'll have to get f of a. In other words, you'll have to go back in and put the a or the b into the function. So that gives you the value of the y value. So that gives you your point here, your x1, y1, and your x2, y2. Okay, so with that now, you now have a point and another point. You don't need the slope. You have the point and the point, but you probably had the slope also. You could have found it through the slope because you knew what you could find the derivative as well. But there's the 2 points going through. 2 points. Is there an equation for that? I think there is, because you have graphs, you have various things in your tables that says if you know 2 points, you can get them. If you know x1 and y1 and x2 and y2, you can find the equation of the line. Or indeed, if you know x1 and y1 and you know the slope at that point, that would do it as well. And finally, the last one, show that the graph of gx contains the point of inflection. What they're looking for here is that as you draw the line here, show that this point here has the point of inflection. Well, the point of inflection was another way of saying you have to do the derivative again. So if you know f dash x, you should be able to get the second derivative. So if it's f dash x was 3x squared minus, I think it was minus 18x plus 15, what's f double dash x? Same thing again, we take down the x squared, we get 2x by 3, that's 6x minus 18. And you could say that is the point of inflection. When is that equal to 0? Well, when x is equal to, well, when 6x is 18 and when x is equal to 3. When x is equal to 3, we can find out the value of g of x. In other words, if we know that the point 3 here is where x equal 3 is the point of inflection on the blue one, we should be able to then plug in the value of x equal to 3 on g of x and find that it's also on that line. So the equation we got for the line, whatever that was, we should be able to say, let's see, when x is equal to 3, is it the same point, is g of 3 equal to f of 3? And if they are, which they will be, you've proven it. So thank you very much for your time. Hopefully that was useful, and hopefully you can now get a half an hour's break, walk around the room, bit of fresh air at the back garden or whatever. And we'll meet again at 11:30. Gur míle mágah, slán tamil.